Imagine pouring warm, thick maple syrup directly into the delicate gears of like $1 million Swiss watch.
Yeah. That's not going to end well.
Right. You wouldn't expect it to keep ticking smoothly, yet functionally, that is exactly what we are doing to our own bloodstream when we just, consume a massive amount of processed sugar.
It is. We treat eating a piece of cake like it's just a simple transaction, right? Like, oh, it's a quick burst of energy and then it just fades.
Exactly. But at a cellular level, it's literally a metabolic crisis.
Yeah.
Welcome to another deep dive. Today, we are unpacking a scenario that, let's be honest, we've all been in.
Oh, absolutely.
You're at a gathering, you eat like a little too much cake or some heavy dessert, and then a few hours later, you're just hit by this sluggish, overwhelming energy crash.
The dreaded sugar coma.
The sugar coma, exactly.
Mm.
So our mission today is to understand the invisible biological chaos causing that crash, and more importantly, to outline the evidence-based shortcuts to immediately flush that excess sugar out of your system. We are drawing our core insights today from a really comprehensive breakdown by the YouTube channel The Health Secret, specifically their video titled, How to Detox Sugar from Your Body Quickly.
And we should probably establish right up front that this isn't about, like, fad diets or weaponizing guilt over eating dessert.
No, not at all.
Right. This is about biological mechanics. We just want to equip you with rapid interventions to regain control of your energy, and your long-term metabolic health.
Okay, so let's unpack this. Let's go back to that Swiss watch analogy for a second. Before we can talk about flushing the sugar out, we really need to understand the structural damage it's causing while it's in there.
Right, with the chaos.
Yeah. So when blood glucose spikes to abnormal levels, the glucose molecules act exactly like that sticky syrup, right?
Mm-hmm.
Like physically gunking up the proteins floating around in the bloodstream.
Yeah, precisely. In biochemistry, we actually call that process glycation.
Glycation, okay.
Yeah. So when you introduce this massive influx of sugar, those glucose molecules literally bind to proteins and lipids. And they do it without the normal regulatory enzymes, like moderating the process.
Oh, wow. So they just attach wherever they want.
Basically, yeah. And this creates these Rove compounds known as AGEs. That's advanced glycation end products.
AGs, okay. Based on that acronym alone, I have to imagine they are literally accelerating the aging process of whatever tissues they touch?
You're spot on. They absolutely do. There's research published in the journal Nutrients that maps out how these AGs accumulate in various tissues over time.
And what do they do once they accumulate?
Well, they trigger severe oxidative stress and chronic inflammation. Mechanistically, they physically stiffen and damage the endothelial lining.
Wait, the endothelial lining, that's the
delicate, microscopic inner wall of your blood vessels, yeah.
Oh, man.
Right. And when that lining is compromised, it sets the stage for cardiovascular disease, diabetic complications, and even significant impairment of your kidney function.
That is crazy. So while we're just feeling a little lethargic on the couch, our blood vessels are actively getting coated in this inflammatory, sticky matrix.
Yeah, it's not a great picture. And the thing is that vascular damage is really only the first phase of the crisis.
Right, because then the pancreas gets involved.
Exactly. The pancreas is forced to respond to all these alarm bells.
Right.
And it has to deploy massive amounts of insulin to manage the surge.
Because insulin is basically the key, right? The signaling hormone that shuttles glucose out of the blood and into the cells.
That's it. But a massive sugar intake requires a massive flood of insulin.
Mm-hmm.
And here is where the metabolic trap really springs shut. Insulin is a strict, uncompromising storage hormone.
Meaning, while insulin levels are artificially spiked from the cake, the body's ability to access stored energy or burn fat is just biochemically locked down.
Entirely locked down. High insulin actively signals the cells to relentlessly store energy, and it completely halts lipolysis.
Lipolysis being fat burning.
Exactly, the breakdown of fats.
Yeah.
So you end up trapped in this biological paradox.
Oh, so...
Well, you have an overwhelming amount of toxic sugar circulating in your blood, right?
Let's say.
But your body is rigidly locked into a storage state, totally incapable of efficiently utilizing alternative energy sources.
Okay, so if insulin is trapping us in storage mode and locking down the whole system, we desperately need a backdoor.
Yes, we absolutely do.
We need a biological mechanism to clear that sugar out of the bloodstream without relying on insulin. Which I guess brings us directly to the immediate triage phase.
Right into triage.
So wait, if insulin is the standard bouncer at the door of the cell that lets the sugar in, are you saying our muscles have a secret VIP entrance?
That's exactly what I'm saying. Skeletal muscle mechanics offer like the single most effective bypass to the entire insulin pathway.
Really? Just muscles?
Yeah. When you contract your muscles, specifically the large, heavy muscle groups, it forces the activation of these specific glucose transporter proteins. They're known as GLUT4.
GLUT4, okay. And these transporters don't need the insulin bouncer to open the door.
They do not. Upon muscle contraction, these GLUT4 vesicles physically migrate from inside the cell up to the cell membrane.
Oh, wow. They move.
Yeah, and once they're there, they pull glucose directly out of your bloodstream to fuel the movement. They completely bypass the pancreatic insulin response.
I mean, that changes the entire paradigm of insulin resistance.
It really does.
Oh.
Even if your body's insulin receptors are completely numbed and failing to shuttle glucose properly, just actively contracting your muscles can still grab that toxic sugar and pull it out of the vascular system.
But I have to question the volume here. Like, can simple, brief physical movements really drain enough glucose from the blood to blunt a massive cake-induced spike?
Oh, the sheer storage capacity of human muscle tissue is staggering.
Really? How much are we talking?
The average adult can store between 300 to 600 grams of glucose as glycogen directly within their muscle tissue.
600 grams, that's huge.
Right. They act as massive metabolic sponges.
Mm-hmm.
In fact, there's a study in the journal Diabetes Care that demonstrated just 15 minutes of mild post-meal walking significantly reduces glucose excursions.
Excursions meaning those dangerous spikes.
Exactly. And that's even in individuals with diagnosed type 2 diabetes.
Okay, so the source material outlines a very specific protocol for this, right? One that doesn't even require leaving your house.
Yep, it's super simple.
It's 3 sets of 15 to 20 bodyweight air squats immediately following a heavy carbohydrate meal.
Which structurally makes perfect sense.
It really does, because an air squat recruits the quadriceps, the glutes, the hamstrings, all simultaneously.
Exactly. You are demanding immediate, intense energy from the largest metabolic sponges in the human body.
So by doing those squats, you are opening millions of those GLUT4 VIP entrances all at once.
Yeah, you're violently pulling the circulating syrup out of your blood vessels and safely into the muscle tissue where it can just be burned off.
Okay, so the muscles can actively pull the sugar out of the blood. But logically, if we want to stop this multi-carb pileup, we should probably also hit the brakes on the sugar rushing into the blood in the first place.
That's the second half of the triage.
So is there a biological emergency brake we can pull in the gut to slow down the absorption?
There is, actually. And it's a highly effective chemical brake. Apple cider vinegar.
Here's where it gets really interesting. Apple cider vinegar. So how does that work?
Well, the active functional component of apple cider vinegar is acetic acid. And it alters the digestive process through 2 distinct mechanisms.
Okay, so if it's slowing down the absorption rate, I imagine it must be physically altering how the stomach empties into the intestines?
That is the primary mechanism, yeah. Acetic acid significantly delays gastric emptying.
Meaning it holds the food in the stomach longer?
Exactly. Instead of the stomach rapidly dumping all those broken down carbohydrates into the small intestine at once, which is what causes the massive glucose spike, the acetic acid forces the stomach to release the carbs in this slow, highly regulated trickle.
Wow. And the second mechanism, it must be interfering with the breakdown of the carbohydrates themselves.
You got it. It actively inhibits the function of specific carbohydrate digesting enzymes.
Like amylase.
Yep, like amylase, right in the digestive tract. There was a systematic review published in the European Journal of Clinical Nutrition that analyzed this.
And what did they find?
They found that consuming vinegar with a carbohydrate-heavy meal can blunt the subsequent glycemic response by an impressive 20 to 35%.
Wait, a 35% reduction? Just from introducing acetic acid?
Yeah. It chemically restricts how much sugar your body can actually process at any given moment.
That is profound. Okay, so the protocol from the source requires exactly 1 to 2 tablespoons of raw, unfiltered apple cider vinegar.
But, and this is crucial, you must dilute that in 4 to 6 ounces of water.
Oh, absolutely. Consuming undiluted acetic acid is incredibly corrosive. Like, it will permanently damage your tooth enamel and aggressively irritate your esophageal tissue.
Yeah, please dilute it. And the timing is equally specific. For the maximum chemical dampening effect, you must consume the diluted mixture roughly 15 minutes before the high-carb meal or immediately after eating it.
Okay, so we've engaged the muscular sponges with the air squats, and we've deployed the acetic acid brake in the gut. Yet there will still be some excess glucose floating in the bloodstream.
There always is.
Right. So the third triage step involves physically flushing it out via hydration. Now, I have to play the skeptic for a second here.
Go for it.
Drinking a glass of water to cure a blood sugar spike sounds almost too simplistic, like a magazine cover health tip. What's the actual mechanical science here?
Well, the necessity is driven entirely by renal filtration, specifically a biological process called glucosuria.
Glucosuria, so sugar in the urine.
Exactly. When the concentration of glucose in your blood crosses a certain threshold, the kidneys recognize the vascular danger. They shift into an emergency filtration mode.
Oh, so they actively try to physically extract the excess sugar molecules and excrete them.
Yes, through your urine, but the kidneys can't perform that extraction dry.
Right, they require a carrier fluid.
Precisely. To force that level of glucose through the renal system, the kidneys demand an enormous amount of water to maintain adequate blood volume and the correct blood viscosity.
So if you're dehydrated, the blood is too thick.
Yeah, the filtration pressure drops and the kidneys simply cannot extract the sugar. The journal Diabetes Care highlights a direct physiological association between higher systemic hydration and a dramatically lower risk of extreme blood sugar fluctuations.
Wow. Okay, so the required protocol here is consuming 16 to 32 ounces of pure water, or I guess unsweetened tea or lemon water, over the few hours following the sugar intake.
Yeah, and you're visually aiming for pale yellow urine. That's the biological indicator that your kidneys possess the hydrostatic pressure necessary to flush the glucose out.
Makes sense. Are there any risks to that?
There is a critical medical caveat here. For the vast majority of healthy individuals, aggressive hydration is incredibly safe. But individuals diagnosed with specific kidney conditions or congestive heart failure often have compromised fluid processing capabilities.
Right, so forcing 32 ounces of water could be dangerous for them.
Very dangerous. They must strictly adhere to their doctor's fluid restriction.
Good to note. So for the rest of us, what does this all mean for you, the listener? It means triage is possible. The GLUT4 activation, the acetic acid, the renal flushing.
It works?
It does. But nobody wants to live in a constant state of damage control, right? Doing panicked air squats in your living room every time you eat a cookie.
Yeah, that sounds exhausting.
It really does. So this pivots our conversation from acute triage, what to do in the next hour, to chronic resilience. How do we repair the underlying machinery so the crash never happens tomorrow?
What's fascinating here is that the shift from acute to chronic management requires addressing that core issue we identified earlier, the insulin trap.
Right, the numbness.
Exactly. When your body is subjected to a constant barrage of sugar and constant spikes of insulin, the cells defend themselves by actively downgrading their insulin receptors.
They become numb to the hormone.
That cellular numbness is the literal definition of insulin resistance.
So if the receptors are numb from constant exposure, I guess the logical solution is to remove the stimulus entirely.
Yeah. We need a period of absolute metabolic silence to allow those receptors to reset and regain their sensitivity.
Enter intermittent fasting.
Enter intermittent fasting. By intentionally restricting your eating window, you force insulin levels to drop and remain at baseline for an extended duration.
There was a pivotal study in Cell Metabolism about this, right?
Yes. It demonstrated that time-restricted eating, such as fasting for 16 hours and consuming all your meals within an 8-hour window, profoundly rehabilitates cellular insulin sensitivity.
The cells finally get a break from the constant screaming of insulin.
Exactly.
And during that 16-hour silence, another vital biological mechanism activates. We talked earlier about those AGEs.
The advanced glycation end products.
Right, the sticky syrup causing oxidative damage. So during that fasting window, the body goes into autophagy, which is basically you can imagine it like a crew of cellular night shift janitors coming in.
That is the perfect way to visualize it.
They sweep through the tissues, identifying damaged proteins, and actively clearing out those toxic AGEs we built up during the sugar binge.
Autophagy is the ultimate internal repair system. It scavenges cellular debris, recycles damaged components, and beyond the cleanup, regular fasting forces the body to develop metabolic flexibility.
The ability to transition from burning glucose to burning stored body fat.
Exactly, whenever glucose is scarce. But the fasting window is really only half the equation.
Right, because the materials you provide the body during the 8-hour eating window dictate how stable the whole system remains.
Exactly. Managing blood sugar chronically requires fundamentally changing the macronutrient architecture of your meals. Starting with protein.
The protocol suggests 30 to 50 grams of high-quality protein per meal. Grass-fed beef, pasture-raised poultry, eggs.
Protein is foundational for two distinct mechanical reasons. First, breaking down the complex peptide bonds of animal protein requires massive metabolic energy.
Oh, right. It has a high thermic effect, meaning your body literally expends calories just to digest it.
Precisely. And second, protein triggers a robust release of satiety hormones in the gut. That effectively neutralizes the intense cravings for processed sugar later in the day.
And then you pair that heavy protein with 15 to 30 grams of healthy fats per meal. Grass-fed butter, olive oil, avocados.
Yeah, and much like the acetic acid in the vinegar, these dense fats physically coat the digestive tract. They slow down the motility of the stomach, ensuring any carbohydrates you do consume are absorbed at, like a glacial pace.
That brings us to the final structural component. Fiber. The protocol mandates filling half your plate with colorful, non-starchy vegetables. Broccoli, Brussels sprouts, bell peppers.
Fiber is crucial. It creates a dense physical matrix in the intestines that actively traps sugar molecules, drastically slowing their entry into the bloodstream.
Plus, those vegetables deliver the antioxidants required to neutralize whatever oxidative stress is generated by the minor glucose fluctuations that still happen.
Right, so you build this perfect defensive wall with your food.
Exactly. Okay, so we have a comprehensive protocol. The acute triage tools, the squats, the ACV, the hydration, and the chronic repair tools. The 16-hour fasting window, the high thermic protein, the fibers matrix.
But there is a silent, completely unconscious metabolic lever that can single-handedly dismantle every ounce of that dietary discipline if you ignore it.
Yeah, the ultimate irony. You could do the squats, drink the sour apple cider vinegar, perfectly balance your grass-fed beef and broccoli.
And completely ruin your blood sugar metabolism simply by staying up until 2:00 a.m. watching television.
It's crazy. Sleep architecture is so critical.
It is the most universally overlooked variable in glucose management. If we connect this to the bigger picture, the speed at which sleep deprivation degrades your metabolic machinery is terrifying.
The Annals of Internal Medicine published clinical findings on this, didn't they?
They did. They showed that a mere 4 nights of restricted sleep significantly obliterates insulin sensitivity in otherwise perfectly healthy adults.
Wait, just 4 nights?
Just 4 nights.
Yeah.
That's all it takes to induce a pre-diabetic cellular response.
Why is the biological punishment for losing sleep so severe and so immediate?
Well, it traces back to evolutionary biology and hormonal regulation. When you deprive the brain of sleep, the body perceives it as an acute survival threat. So it floods the system with cortisol.
Our primary stress hormone.
Exactly. And evolutionarily, cortisol's main job during a crisis is to dump massive amounts of glucose into the blood to fuel a fight-or-flight response.
Oh, wow. So your late-night television binge triggers the exact same metabolic cascade as fleeing from a predator.
Yep. Your blood sugar is artificially elevated by stress, completely independent of what you ate.
And I imagine this evolutionary panic also scrambles the signaling hormones in the gut.
It derails them entirely. Sleep deprivation triggers a massive spike in ghrelin, the hormone that violently signals hunger.
While simultaneously suppressing leptin, which is the hormone that tells you you're full.
Exactly. Your body is biologically tricked into believing it is starving. And because it's operating under a perceived stress threat, it specifically craves high carbohydrate, sugary foods for rapid energy.
So you are fighting a war on 2 fronts. Your gut is screaming for sugar, your blood is flooded with cortisol, and then there's the neurological impact.
Yeah, the brain takes a hit too. Sleep deprivation actively impairs the prefrontal cortex,
which is the executive center of the brain responsible for impulse control.
Exactly. When the prefrontal cortex goes offline, your rational ability to choose the broccoli over the cake evaporates. You are just left with this impulsive, primitive drive demanding immediate sugar.
Wow. Okay, so to protect the metabolic system, the protocol is rigid. 7 to 9 hours of uninterrupted sleep every single night, maintaining a consistent circadian schedule even on weekends.
You really must optimize the environment. A cool, pitch black room. Ruthlessly eliminate blue light exposure, caffeine, and alcohol before bed.
Because even though alcohol might make you feel sleepy, it fragments your REM cycle.
Oh, it absolutely destroys your restorative sleep architecture.
Right. So when we pull all of these complex threads together, a very empowering picture emerges. Sugar management or repairing a damaged metabolism does not require purchasing expensive supplements.
No, it doesn't.
It doesn't require suffering through some extreme juice cleanse. It's about utilizing biological levers you already possess. You dictate GLUT4 activation through physical muscle contraction.
You control gastric emptying via the acetic acid and apple cider vinegar.
You force renal filtration through aggressive hydration.
You repair receptor sensitivity using the metabolic silence of intermittent fasting.
And you regulate your systemic hormones through protective sleep architecture.
These biological levers operate synergistically. So the challenge for anyone listening to this deep dive is to isolate just one of these mechanisms and apply it today.
Just one.
Yeah, you do not need to overhaul your entire existence by tomorrow morning. Perhaps you commit strictly to a 10-minute walk after your heaviest meal to open those GLUT4 pathways.
Or implement a simple 12-hour overnight fast to initiate a baseline level of autophagy.
Exactly. Observe the mechanics of your own body and watch the compounding results as you progressively layer these biological habits.
Start with one lever. And as we wrap up, I want to leave you with a final paradigm shift derived entirely from the conclusion of our source material.
It's an important one.
It really is.
Yeah.
We've been taught for decades that resisting sugar is this moral battle, a test of willpower. But what if you stopped looking at a sugar binge as a personal failure and simply started viewing it as a biochemical equation?
Right. Take the emotion out of it.
Exactly. When you put an input of excess glucose into the system, you don't need guilt. Guilt is metabolically useless. You just need the correct biological output, muscle contraction, hydration, and sleep to balance the scale. Think back to that multi-carb pileup in the bloodstream. You are not a helpless bystander waiting for the crash. You control the traffic lights. Your metabolism is fully within your control. Thank you for joining us on this deep dive. We'll see you next time.